Next section in chapter 5, section 4. We're going to break this up into two parts. So we got part 1 today. Part 2 will be tomorrow. We are solving radical equations. Solving equations. You guys have been solving equations since pre-algebra. So hopefully we remember some stuff about solving equations. We're just adding the spin on it of throwing the radicals in there. But we can handle them. It's not too bad. So first off, a radical equation is an equation that contains a radical expression with a variable in the radicand. So, an equation has an equal sign. So we're going to be dealing with things with equal signs. Radical equation has a radical in it where the variable is under the radical. That's what a radical equation is. To solve a radical equation involving a square root, first, use properties of equality to isolate the radical on one side of the equation. So, that's just us using our inverse operations. What's the inverse of addition? Subtraction. What's the inverse of subtraction? Addition. What's the inverse of multiplication? Division. What's the inverse of division? Multiplication. There we go. We know our inverse operations. We still have to use our inverse operations when we're dealing with radical equations. So the first step is to get the square root completely by itself, where nothing's being added to it, subtracted from it, multiplied by it, or divided by it. So we want the radical by itself on one side of the equation. Then we're going to use the following property on the next slide to eliminate the radical and solve for the variable. Can I move on to the next slide to see the next property? If two expressions are equal, then their squares are also equal. So if I have a equals b, then I know that a squared also equals b squared. So to get rid of a radical, I can take the square, or I can square both sides, and that'll cancel my radical out. If I square one side, I have to square the other. Everyone okay with that concept? Any questions so far? Can I move on to my examples? Or are we still writing? All right, example 1. Solve each equation. Letter A, I have the square root of x plus 5 equals 13. Square root of x plus 5 equals 13. Right now, as it is my radical by itself. No, what do I have with it? Plus 5. So I'm adding 5 to it. What's the inverse of addition? So I need to do what to both sides here? Subtract 5 from both sides. 13 minus 5? 8. Everyone go with that first step. Is my radical now by itself? Yes, it is. Based on my previous slide, what am I able to do now to both sides to get rid of my radical? Square both sides. If I square a square root, it gets rid of the radical. What's 8 squared? 64. There's my answer. Not too bad? Now on your assignment, it's going to tell you to check your solution. I do want you to check it. How do I check my solution? Plug it back into my original problem. And then I work down both sides. What's the square root of 64? 8. What's 8 plus 5? Does 13 equal 13? Yep, so it checks out. If it asks you to check your solution, you must check your solution. You need to show all your work too. Don't just sit there and do it in your head. I know most of us can probably do this in our head. I want to see your work. If you can do the work in your head, you can do it on paper as well. Questions on 8? Letter B. Is the square root by itself? No. What's one thing I need to do to get the square root by itself? I can subtract 3 from both sides. Look at the negative square root of x equals negative 3. What's the next thing I need to do to get the radical by itself? Do what?
Add 1.
Not yet. I'm not squaring yet. I'm not adding 1. Divide by negative 1. This is like negative 1 times the square root of x. So we divide by negative 1 on both sides. Everyone good with that? Now what can I do? Because my radical is now by itself. Square both sides. I get x equals what? 9. Another way I could have approached this, instead of subtracting 3 from both sides, I could have added the square root of x to both sides. That'd give me 3 equals the square root of x. Is the square root by itself? Yep, so it just deleted the step of dividing by negative 1. Either way, it will still work though. Checking my answer. What's the square root of 9? What's 3 minus 3? Does 0 equal 0? Yes, it does. Ask you to check your solution, check it. Questions on example 1? Not too bad? All right. Example 2. Solve 4 times the square root of x plus 2 plus 3 equals 19. Is my square root by itself? No. Remember, we want to get our square root isolated by itself on one side of the equation first. So it's almost as if this square root is like a variable. If I was just given this equation, what would be my first step to get x by itself? Subtract 3. What would be my next step? Divide by 4. So I'm going to do the same 2 steps. Instead of just x, though, I have the square root of x plus 2. So what did we say the first step was? Subtract 3. What's 19 minus 3? 16. What did we say our second step was? Divide by 4 on both sides. 16 divided by 4 is the radical now by itself. Yes, indeed. Since the radical is by itself, what am I able to do to both sides now? Square both sides. So that gives me x plus 2 equals what? What's 4 squared? 16. My end goal for solving any equation is to do what? Find the solution and get the what by itself? My x or any variable that I'm solving for. Is my x by itself? Nope. So now I have to solve this equation. How do I get x by itself? Subtract 2 from both sides. So x equals 14. Questions on example 2? Check it real quick. What's 14 plus 2? Square root of 16? 4 times 4? 16 plus 3? Does 19 equal 19? Yep, so it checks out. Questions on example 2? Can I move on? Huh? Almost. Example 3. Oh no. We got square roots on both sides now. Uh-oh. I've got to solve the square root of 2x minus 1 equals square root of x plus 4. Anyone have any ideas what I can do? What? Not square root. They're already square rooted.
Or square root.
Yep, just square both sides. Now I just have an equation with variables on both sides. Bless you. If I have a variable on both sides, do I want to deal with my variables first or my constants? What? Variables. Why?
So you have a number on the other side, just a y side.
Not quite. Sometimes our equations, if we move our variables to one side, they cancel each other completely out. You guys remember that from probably a little bit in pre-algebra, from Algebra 1, and from this class a little bit? They canceled it out. We were left with a true statement. It was all real numbers, correct? If my variables cancel each other out, and I was left with a false statement, I got no solution. Right? That's why we like to deal with the variables first, just to see if they cancel each other out. If they don't cancel each other out, then we're good. We can just keep on moving along. So what do I need to do here to get my variables on the same side? Subtract x from both sides. 2x minus x. What? Not 2. Just x, or 1x. And then how do I get x by itself? Add 1. X equals 5. Plugging back in, I have to plug in for all my x's. On the left-hand side, as well as the right-hand side. What's 2 times 5? 5 plus 4. 10 minus 1? Square root of 9. Square root of 9. 3 equals 3, so it checks out. Questions on example 3? Not too bad? Can I move on? Oh no. Don't have a square root. We have a cube root. Solve the cube root of 5x minus 2 equals 12. Anyone have any thoughts on what I could do here? Not cube root.
Huh?
Not cube root.
Oh, wait, no. Cube.
Yep. If I have a cube root, I can just cube both sides, and that'll get rid of my cube root. So I get 5x minus 2 over on the left-hand side. 12 to the third power will give me 1,728. If I had a fourth root, what would I do to both sides? Do the fourth power on both sides. If I had the fifth root, I'd take both sides to the fifth power. Everyone understand that concept? What's my first step to get x by itself? Add 2. What's 1728 plus 2? 1730. Last step. Divide by 5. 1730. Divided by 5 gives me 346. Five times 346, 1730. Cube root of 1728 is 12. So it checks out. Questions on example 4? Not too bad? Can I move on? There it is. Pages 268 through 269, numbers 4 through 44 evens. So we do Friday, April 23rd on Canvas. We're hopefully going to get a lot knocked out in this next 30 minutes of class. I do need everyone working quietly. I'm going to throw the book page up on the board. I'll play some music for y'all. Does anyone have any questions before I end my recording? Not too bad of notes? I apologize, it wasn't 13 minutes. It was about 15, 16 minutes. That's okay.